The next concept in this potential energy is very, very important concept. So all of you observe that. So that is the concept we'll take about light. You can take, for example, your staircase. So I'll consider only 2 steps. Okay. So imagine this is the step number 1. Step number 1. Actually, this is a ground. So I'll consider what is this one, everybody? Ground. So the step number 1 is present. Let me consider you are at initial at point A. Now this is a point B. Now which is above from the ground at H1 height. What is that height, everybody? H1 height. Understanding? Then you have taken the next step, which is another step, and you have been reached here. So initially you are at here at A point. So finally you reach to the A to B, B to C, C to D, and finally you reach your destination E. Okay. So let me take RL some mass you consider. Your choice. So whatever it is. I hope you all understanding, everybody, what I'm saying. Clear?
Yes, sir.
Yeah.
Yes, sir.
So now, this height from the sea, let me consider as a H2. What is that, everybody? H2. Understanding? Now, as we know, this is the initial point. All of you remember that. This is the initial point. And what is your final destination? This is your final point. Am I right? All of you?
Yes, sir.
That is what finally reached here. That is what I will say total height. So which is actually call it as a final point. So you reached here. So now what I want to say exactly here. So all of you keep it in mind. No work is done in displacing. When you are moving from B to C, there is no work is done. When you are moving from D to E is also no work is done. So because you are moving in this both the cases horizontal to the surface. So at a given height, please remember, suppose if I take, this is my first floor building. Now if I am in terrace at this corner, so whatever I have taken a potential energy, suppose imagine from the ground, whatever I have reached to the maximum height is my terrace. So above the terrace, if I keep on walking from one point to another point, so at every point in a given horizontal height, at every point I'll possess the same potential energy. Do you understand what I'm saying, everybody? Are you clear? All of you? Yes. So that is what exactly I want to say you. So at a given horizontal level, at every point, the potential energy remains what? Remains constant. Do you understand, everyone? So only when you changes the height, that is what position above the ground only, the potential energy will increases or the potential will decrease. If you are moving at a particular height continuously, even 10 kilometers, the energy possessed by you remains what? Everybody?
Constant.
So now, forget about it. Let me consider. What is the potential energy to move from A to B? Let me take work done. So W1. So what are you take work done? So W1 I'll take. Work done to move from A to B. What will happen? Anybody? A to B. Work done from moving from A to B, which is equals to what? Please respond. MGH. H means what? H1. Work done from moving from B to C. So I am at B point. I reached here. Height is remains H1 only. If I take every point, it is H1 only. So remains my work done is what? From A to B.
Constant.
A to B, my work done is W1. From B to C also, my work done is remains what? Everybody, MGH1 only. Am I right or wrong? Please respond. So what is the change in my work done? No change. No displacement. So I am moving in the same position so that the height is not changing. So work done remains constant. Again, I am moving from C to D. Then what is my work done? Again, I am moving from C to D. Everybody. Yes, please. So B to C, work done is not MGH1, which is equals to 0 because no change. Your position is not changing. So your body is having the same potential energy, whatever you have. From C to D, again, height is increasing. So what is the work done? Work done
MGH.
equals to MG. What is that? H2.
MGH.
Q. So now if I make total, so total work done is equals to, what is that? W1 plus W2, which is equals to mgh1 plus mgh2. So both the cases, mg is common. I'll take h1 plus h2 outside. So if I join h1 and h2 together, which is equals to something, what is that, everybody? You check it here. Up to here and up to here. Both the heights, if I add it, what will happen? h1 plus h2, both if I add it, I'll get what? All of you? H will come. Okay. So that is what? So potential energy or work done to reach that height is equals to mgh, which is only is equals to potential energy possessed by the body. All of you understanding? So what I want to say from this, simply I can put a statement, but I want to teach you the statement that the work done or potential energy does not depend on the path followed by the body. So write it, everybody. Very important statement. The work done or the potential energy, work done or potential energy does not depend on the path followed by the body, does not depends on path followed by the body, does not depends on path followed by the body, but depends only on the initial and final positions. I hope you all clear, everybody. Only it will depends on initial and final positions. Clear, everyone? So irrespective of the path which it has been reached there, it will only depends on only the initial height and final height. So that is what you have to remember. Okay, guys?
Yes, sir.
Yes, sir.
Do you understand, everybody? Clear, everyone?
Yes, sir.
Yes. So that is what it is. Now, you take many examples. For example, the potential energy of a body taken to a height h using a staircases. So you can take, suppose if you want to reach your suppose this is my initial point. So if you want to reach your terrace, so there is a many ways. You can directly, like with a rope, you can tie one rope and you can climb it, or you can use a staircase and you can climb it, or something. Suppose if you want to keep an object above it, directly you can throw it, or you can take with the help of steps and you put it, or you can directly some other, suppose you are in another terrace. So from here to here you have been thrown. So whatever you have been used out. So finally the object will possess the same potential energy. So what is, it will never depends on the path which has been followed, only depends on the position, initial position and final position it is, which the object has been present at the initial and as well as the final. I hope you all clear, everybody. So write the question. So if suppose if you take a moving ceiling fan possesses what energy? Suppose a fan is at rest. Suppose this is our ceiling. Now you all can notice it. So the moving ceiling fan, the fan is at rest now. Let me consider it. So what is the energy it is possessing? It is in state of rest. State of rest above from the ground. above from the ground. So what energy it will possess? Anybody? What energy?
Zero, sir.
No, zero. Oh shit.
Gravitation.
Only it will possess position above from the ground. So it will possess what energy? Potential
Gravitation.
Potential
or
energy.
gravitational potential energy. Suppose if I on the switch, then it will start rotating. Rotation, motion also it is there. Then what energy it will possess?
Kinetic energy.
Both potential energy plus kinetic energy, because above from the ground kinetic energy, potential energy, and then you are moving, then it is what energy? Kinetic energy. Do you all understand, everybody? All of you?
Yes, sir.
Write it. Clear, Amma? All of you understand? So solve one question, then we'll finish it. Right, a body of mass 10 kg, a body of mass 10 kg, a body of mass 10 kg is kept at a height of 5 meters. Is kept at a height of 5 meters. Is kept at a height of 5 meters. Calculate the potential energy of the body. What is the answer? Answer, please. This much time. What is the answer? So potential energy is equals to mgh, which is equals to mass. How much mass? 10 kg. Acceleration due to gravity 10 meter per second square. Height is 5 meters. So over. So 100 into 5, which is equals to 500 kilogram meter into meter square per second square, which is equals to 500 joules. So potential energy possessed by the body is equals to how much? But your side you write 1 kilogram meter square per second square is equals to how many joules? 1 joule. So that is what you have to do it. Clear, everybody? Yes, please. Understand, Amma?
Sir, can you please repeat the question? Due to network issue,
Right.
I'm
A
unable
body
to.
of mass 10 kg. A body of mass 10 kg. A body of mass 10 kg is kept at a height of 5 meters. Is kept at a height of 5 meters. Calculate the potential energy possessed by the body. That's all. Understand, everybody?
Yes, sir.
Yeah. So that's all about it. So we can solve up to here. Then we'll continue from here. Okay. So I hope you all understand what is potential energy. Then tomorrow we'll see transformation of energies and then power, and we'll find out. Clear, everybody? Yes, please. Yeah. Thank you.